This diagram illustrates the iterative nature of the Agile model. Unlike waterfall, we loop back after testing to refine the features based on feedback.
The correlation here is significant. Now, if we look closely at this trend line, it indicates a major shift in the demographic distribution.
You need to understand the fundamental principles. This will be on the exam. It's crucial for your future as engineers.
You know, the ultimate goal of software engineering has honestly always been exactly the same. We all just want to build high-quality software, get it done on time, and keep it within budget. Simple, right? Well, the goal hasn't changed, but the how definitely has, radically. Today in this explainer, we're going to trace that massive evolution. We're going from the days of strict, manual planning all the way to the cutting-edge, intelligent AI pipelines that are running the modern web right now.
So, here's our roadmap. First up, we'll look at the foundations of Agile software. Then, we'll move into the DevOps automation revolution. Third, we're covering DevSecOps and secure coding. And finally, we'll wrap up with the MLOps lifecycle.
All right, let's dive right into part 1, Foundations of Agile Software. Historically, the absolute biggest bottleneck for developers was the rigid, sequential planning of the waterfall model. Picture this, you're halfway through building something and the customer suddenly changes their requirements. With waterfall, you are essentially stuck. It was a nightmare. The Agile approach completely shattered that paradigm. By shifting over to an iterative model, teams could suddenly prioritize having actual working software and rapid adaptability over those massive, inflexible plans. It was a total game changer.
Now, Agile really succeeds by structuring human collaboration, and it typically does this using the Scrum framework. It basically eliminates confusion by dividing the work into a lean triad of roles. You've got the product owner, who defines the what, then you have the development team, who figures out the how and actually builds the software, and finally, the Scrum Master, who steps in to clear out any roadblocks. It's an incredibly efficient structure designed purely to keep momentum going.
And here is the best part. Instead of those massive, comprehensive documents that used to take literally months to draft, Agile relies on the beauty and simplicity of the user story. Take a really simple requirement, like, as a customer, I want online payment so that I can pay quickly. Because it's written strictly from the user's perspective, it gives the engineering team immediate clarity on what is needed and exactly why it's needed. They can just take that and start building right away.
Okay, moving right along to part 2, the DevOps automation revolution.
So, Agile got the code written fast. That's great. But then teams hit the classic wall of confusion between development and operations, which slowed actual deployment down to an absolute crawl. The ultimate bridge across that wall? The CI/CD pipeline. By automating the entire flow, going from code commit to build, through testing, all the way out to deployment and monitoring, DevOps ensures continuous improvement. Plus, it creates a shared responsibility across the entire software lifecycle.
To actually make this level of automation a reality, the industry rallied around a core stack of essential tools. You've got Git, which serves as your single source of truth for version control and collaboration. Then there's Docker, which wraps the application in lightweight, portable containers so it runs exactly the same everywhere. And finally, Kubernetes. Think of Kubernetes as the conductor of the orchestra. It handles all the heavy lifting of scaling, load balancing, and even self-healing if a container suddenly crashes.
But listen, the pipeline doesn't end just because you deployed. Blazing fast software is completely useless if you have no idea it's failing in the real world. That requires observability. It acts essentially as the flight recorder for your application. Using powerhouse tools like Prometheus and Grafana, teams rely on the 3 pillars of logs, metrics, and traces. This is how you monitor application health in real time, all the time.
Which naturally brings us to part 3, DevSecOps and secure coding.
Now, speed is fantastic. We all love speed. But what happens when you automate bad code? Without tight security, a highly efficient CI/CD pipeline just becomes a machine for deploying bugs and vulnerabilities at record speeds. No one wants that. This terrifying reality is exactly why DevSecOps was born. It's all about baking security directly into the pipeline from day one.
The core philosophy we're talking about here is shifting left. Basically, moving your security testing as early in the development lifecycle as humanly possible. By utilizing static code analysis tools like SonarQube, developers can actively scan their source code for vulnerabilities before the thing even compiles. Finding a bug at this stage is infinitely cheaper and way safer than finding it later when it's live in production.
So what exactly are they scanning for? Well, the usual suspects. secure coding practices have to aggressively defend against the OWASP top 10. We're talking about major threats like cross-site scripting, broken authentication, security misconfigurations, server-side request forgery, and yes, believe it or not, decades later, we are literally still fighting SQL injection. Automated container scanning and testing make absolutely sure these critical vulnerabilities are neutralized before they ever see the light of day.
And finally, let's step into the future with Part 4, the MLOps lifecycle.
Throwing machine learning into the mix means we need a completely new operational pipeline. MLOps definitely echoes the CI/CD pipeline we talked about, but with a massive shift in focus toward data. This cycle kicks off with data collection and cleaning, moves right into model training, and requires strict versioning of those massive datasets. It's a continuous loop where your deployment and your monitoring are constantly feeding back in to retrain the models. Now, in the real world, you aren't doing this heavy lifting on your laptop. It happens on massive cloud platforms. We're talking about the titans here. AWS SageMaker for robust training and monitoring, Azure ML Studio for rapid AutoML, or Google Vertex AI for end-to-end pipelines. These giants provide the essential infrastructure. They host the APIs that allow a super simple mobile app right in your pocket to instantly leverage a wildly complex machine learning model running up in the cloud.
But as we automate actual intelligence, the stakes get significantly higher. Managing AI isn't just about the code anymore. It requires absolute guarantees on privacy, fairness, accountability, and transparency. Deploying a model with inherent bias or one that violates data privacy laws like GDPR, that isn't just a basic bug. It's a massive compliance risk and a catastrophic failure of the whole system. These pillars act as non-negotiable engineering requirements.
So let's put it all together. The ultimate state of modern software? It is automated, secure, and intelligent. We started with Agile to optimize our human collaboration. Then we layered on DevOps to automate the delivery. We integrated SecOps to ensure every single release is bulletproof. And finally, we added MLOps to continuously train intelligent models. Each era builds directly and powerfully upon the last. I want you to take a hard look at your own team's practices today. Think about the way you plan, the way you deploy, and exactly how you manage your data. Are you merely building software for the past, or are you truly engineering for the future? Keep learning and keep automating. Thanks for joining me on this explainer.